Hello all, welcome back to our channel. So in today's section with respect to GD&T, we will see what are the different types of tolerances. There will be two types of tolerances. One is unilateral. Second one is bilateral. First of all, I think in the previous sections we have seen about what is the use of this tolerance. In order to summarize it, for making a part, we need a dimension with respect to a tolerance which is a mandatory. None of them or none of the machines can able to produce a part exactly. So there will be some deviations, which is called as limits, wherein the part can be deviated after manufacturing. So that deviation should be within the limits. So that limits is provided with some values which is called as a tolerance. So there are two types of tolerances. One is unilateral and other is bilateral. So first one, coming to unilateral, as the name itself indicates, uni means one side. So that one side, upper side or lower limit, upper limit or lower limit. So that is called as a unilateral tolerance. Just with an example, I am considering a shaft. With a diameter of 20, okay, so 40, we can take any, plus 1 minus 0. So this is the indication, plus minus some value. So it can be applicable for circular as well as the normal square or any dimension. Suppose I have taken a plate like this, I can give here 50 plus 1 minus 0, or 50 plus 0 minus 1. So this unilateral tolerance can be applied anywhere. It cannot be a circular component. It can be circular as well as the non-circular components from surface dimensionings and all. So in this case, I have taken this as an example, just diameter 40 plus 1 minus 0. So in this, it can go up to 40. So here maximum is 41 and minimum is 40. Maximum diameter is 41. It should not go beyond 41. Minimum is always 40 because it is 0. 40.1, 40.2, 40.3, 4, 5, 6. It can go up to 41. And minimum, it should not go 39.9, 39.8. Why? Because it is 0. So if you observe here, only one side of the diameter is increasing. It is not decreasing, because we have given unilateral tolerance. How can we decide it is unilateral or bilateral? Based on the application. We should not decide like for plate we have to give this one unilateral. For shaft we have to give bilateral. It's not like that. If you are manufacturing two components at a time, based on the requirement and based on the material, based on the manufacturing process, we have to decide whether we have to give unilateral tolerance or bilateral tolerance. So it depends on form, fit, function. Form, fit, function means how the part is going to assemble with respect to form, fit, how much tight it is, and function, what is the function, how it is going to get affected based on the tolerance, and form, how this shape of the product is affected with respect to the tolerance. So we have to take all those things into consideration in deciding unilateral or bilateral. We just simply, we should not give, okay, this part is we can give unilateral, this can go up, it cannot go beyond. So similarly, if I give as my wish, suppose if I given 40 plus 1 minus 0 here, and for the shaft if I give 38 plus or minus 1, then at the worst case condition the part is going to get fail. So we have to be careful while deciding whether it is unilateral or bilateral. Okay, coming to the concept of unilateral, this is what the concept, diameter 40 plus 1 minus 0, this diameter 40 can go up to 41 because it is given plus, and in minus it is 0 because it should not go beyond 40, so less than the 40, right? So similarly, diameter 40 plus 0 minus 1, or we can take minus 2 just for example. So this is also called as a unilateral tolerance because we have seen this concept here. So this one, it should not go beyond 40 because it is upper limit is 0, maximum is 40, minimum is 38. So it can be 38 and 40. Minimum is 30. So beyond this 38, it should not go. It can be 38.1, 38.2, 38.3 something, up to 40. So it cannot be 37.8, 37.9, it should not, because the limit itself is saying that 40 minus 2, which is equal to 38. So the diameter should not go below 38. It can go beyond 38. Beyond means extra, over 38, and it can reach up to a maximum of 40. Right? So this is what about unilateral. I think you can understand this. Next. Diameter 40 plus or minus 1. This is called as a bilateral, plus or minus. It is combined and we will get only one value here. In unilateral, you are going to give separate tolerance, upper limit and lower limit. But in bilateral, upper and lower limit, we have only one, we will give only one tolerance value, 40 plus or minus 1. So that means it can go to 41 and lower limit can go up to 39. In the previous case, we have seen only 40 and lower limit is same value. Upper limit is 41. But in the present scenario, since we have given bilateral tolerance, upper limit is 41 and lower limit is 39. Similarly, here 50 plus or minus some 2 example. It can go up to 52 and 48. 52 and 48. This is the tolerance. We are giving this dimension 50 plus or minus 2. So it can go up to 52 and this is 48. Right? So this is the use of unilateral and bilateral tolerance. So next concept is we'll see about nominal size. It's a small concept. And actual size. So what is the difference between the nominal size and actual size? So nominal size is nothing but the dimension given on a particular drawing. Dimension given on a particular drawing. Actual size. Dimension achieved on final product. Final product means after manufacturing. So nominal size is nothing but this size dimension which are all available on drawing we call as a nominal sizes. And actual size is the size achieved after manufacturing the part. That we call as a actual size. Difference I can say. If I take a shaft, this is having suppose example of diameter 30. So this 30 is shown on the drawing plus or minus 1. It is shown on the drawing. This is called as a nominal size. What does this indicate? This indicate this part, this shaft can go diameter 30.1, 30.2, 30.3 like that up to 31, and this can go 29.9, 29.8, 28.9, 28.8, 28.7 up to 29. Just reverse it. I have written wrongly. So this can go up to 29 only. Right? We don't know. We have given in drawing as 30 plus or minus 1, but once it is manufactured, once it is produced, we don't know what value we will be getting. We may get 30.3 or we may get 28.9 or we may get 28.7. or we may get exactly 29. We are not sure. Right? So this is called a nominal size. Then after manufacturing this part, after getting the output of this product, if you measure, that can be 30.5. It is within the tolerance zone because we have set the limit. After manufacturing, we got this as 30.5. This is called as actual size of the part. Got it right? Nominal size is the size of the drawing or dimension of the drawing, dimension of the part available in the drawing. Actual size is the actual exact size of the part which is measured after manufacturing. Right? This is what the concept of nominal size and actual size. I hope you understand this concept. And with this, we will close this section. And in the next section, we will see, or I will come up with a different concept, like what are the, I think we can able to cover what are the sample questions which can be asked in an interview. I think I can able to cover those things. If not, I'll come up with a different concept of GTOLs and all. Yeah, with this I'm going to end this section. I hope you understand this one. Please subscribe to my channel and select a bell icon which is available. In that, some bell icon will be there. If you select this one, you'll get notifications as soon as I post any content. Yeah. Thanks for support and thanks for watching. Thanks. Bye.